Okay guys, I'm filming this part from inside the office because I just got home and this package come in the mail today. This is from our good friend Joe. Joe sent us several other items before. So we'll get this opened up and see what Joe has sent in for this today. I've been waiting on another package. It's coming from China, and I can actually say that China was able to get the package here in the US quicker than our postal service can get it from New York to North Carolina. Strange, huh? Supposed to have been delivered yesterday. It did not come. I come home today and they still have not delivered it. Still waiting on postal service, and that item will be very interesting when you see it. I have no idea what Joe has sent in here, but we'll open it up and find out. Yes, I'm really wanting that other package from China because I think it'll be a very exciting piece of equipment to have here in the shop. Oh boy, looks like Joe sent a lot of stuff. Here we have a set of voltmeter probes. Okay, so I had to stop because I had a horn blowing outside. Oops. Okay, actually I had to stop because I had a horn blowing outside, and I looked and it was the USPS truck. So my other package came, and I'm gonna do that in another video. So back to 1-inch wafer switch. Open slowly. Alright, let's check this out. I hope the lighting is okay in here. It's not the best. I want to put some more lighting in the office, and I actually might start doing some more YouTube videos here in the office. And oh, okay, I know what these are. If you remember, I worked on a piece of equipment at one time, and I can't remember exactly what it was. I also got to use my other tripod because the carpet in here makes the camera wiggle. But if you look inside here, these are actually the inserts that go in wafer switches. Now, I did a video before, I can't remember exactly what it was, but we had these little pieces was missing in it. Well, Joe has sent us some. Well, thank you, Joe, for that, because I don't have any, and I actually had to make the one. I can't remember what that piece of equipment was. Sometimes getting old, your mind just don't stay with you like it should. Anyway, let's see here. We got some 7.5K 1-watt resistors, a little bag of them. And I'm on the other side of the camera. I'm usually on the left hand side of it, but what I'm shooting at right here, I got another TV over here I got to move and give me some more space here on this workbench. And here's a package of cotton swabs. You can see a little, like 1/8, maybe 3/16, 3mm style cotton swabs. These will come in handy for cleaning up circuit boards. I've got a lot of stuff in this here. Back. Plug. 5 each. Not sure what it is. Let's open it up and see. Okay. They are the banana jack plugs. And you see it up here at the front, it has the standard size. Then it goes down to the 2mm. Now, you know, this is really scary because I got a piece of equipment here that in fact, you saw the ESR meter that uses 2mm plugs. That should fit right in. Wow, Joe, you can read minds. In fact, you sent stuff before you got the video up. Let's see, we got some more plugs here. Okay, basically the same thing. Now, yeah, the same as the other ones. Now, I like these right here, and I've been looking for something like this. You notice this has the screw-off piece here, where your tip screws out. Now, you remember the old Heath kit RF probes and audio probes? You know, little aluminum or aluminium for my overseas friends. And they got two plastic caps on each end, and they got the identical tip like this on the end of it. Well, I'm wanting to make some, but the problem was it's those plastic caps on each end. So to reproduce them, you would have to make those plastic caps. Well, these are the ends that would fit on those. And in the next video, or video to come, you will see exactly what I'm talking about. And I'm not going to try to give too many spoilers out on that yet. Alright, this package not been opened. Plug tip 5 each, and yes, these are the same. Lead test 1 each. Right, let's see, some of this stuff has not been opened. Not sure where go run across this stuff. Oh God. These are the same type of plugs that were used in some of the older Simpson 260s. The silicone coated wire. You notice the 2mm plug. This is for the older type Simpson voltmeters, not tube type, solid state voltmeters. I think they were from the 50s and 60s. I happen to have one of those out in the shop that was tore down, and found that it wasn't no good. Okay, these are more of those other black tips that you saw. Cobra Industries lead test set. Cobra. I'm going to open this and see what's in it. No idea. But it has Cobra, like Cobra CB. I don't know. No, they are actually more test probes. Big alligator clips. And the same type of probe that we were just looking at. Oh man, those are nice probes. That'll come in handy. And looks like we have another, it just says lead test. There's a black one, has the 2mm test lead. That's all it has on the little tag here. It's another one of those Cobra test probes. Here we have one with the standard size banana plug and alligator clip. And Joe just sent a lot of stuff this time. And here's a red one with the 2mm to alligator. and good quality wire. These are the silicone type wires, very flexible, very durable. They will last a long time. Some D313s, and got my name on it. And these little transistors. D315Es. 0.750 mega ohms. Quarter watt, 5% tolerance. Pack of resistors, like, I don't know, about 50, 60 of them in there. Quite a bit of them. 5K, 5 watt, 5% resistors. They come in very handy. Good flame proof resistors. And we got a couple of these big old potentiometers. They look like they may be audio tapered. Let me get one of them out to see. We got 2 of those. There's another one here. Appears to be the same. See just how nice they are. It's got a part number on it if you can read that, but it doesn't tell me what the value is, so I'll have to grab a voltmeter. I don't have one here in the office, and check them out, see what they are. Boy, that's a heavy duty rheostat there. Big nice heavy duty ceramic base, ceramic end. Even have the connectors on it to hook to it. Very nice heavy duty. There's a 1/4 inch extension shaft with the keeper on there so you can mount it to the chassis, and then you can stick out the front and you hook to the back of it. Good extender shaft. There's some brass hinges. It might come in handy for some vintage radio. Central Labs PA-2011 4-pole 6 position non-shorting. That sounds like some type of a wafer switch. And just what it is. Check that out. Big long shaft, about 2.5 inches. 4-pole wafer switch. 2 position. That works good for like some of the vintage radios when you got multiple contacts to switch back and forth. We actually sent 2 of those in. They say 6 positions. I bet it's got a lock on it. You have to change the lock, so this would actually be used as a mode select switch or part of a band switch. Yeah, but you have to move the lock to get each position. Right now it's only set for 2 positions. But yeah, we got 2 of those. Real nice. And Joe, I sure appreciate this, man. This stuff will come in handy. Parts like this will used up real quick. So thank you very much, Joe. Well, hello everyone. Hope everyone's doing good in the office again. And one reason why I wanted to start doing some videos here in the office is because of this package here. I think this is a piece of equipment that is going to really be nice to have here in the for shop use, you know, to do some things. But been waiting on this a long time. It's finally arrived, and this, I will go ahead and tell you, this was sent to me by Banggood to use and put together and review, but mostly we'll probably do a lot of videos on this piece of equipment. Now you can see it's a pretty large box. So what has Banggood sent me? Well, let's go ahead and crack into this thing. Like I say, it's not going to be a as much as a review video as it will be a video that will be something to be used here in the shop or here in the office for shop stuff. Now I'll probably set up a space, if I can find a space, out in the shop to take this out from time to time to use in the shop. But it'll probably both be used here in the office. Seems to be packaged up pretty well. And as you can see, you still don't see nothing. Let's turn around here. And we'll go ahead and take this off. What we have here is the Anet A6 3D printer. And I think GearBest sells a lot of them, but Banggood also carries this. And it's a do-it-yourself printer. It's everything you need in here for the printer. So I'm going to go ahead and move the box out, and I'll pour the two trays out, and we'll get them here on the table and take a look at it. Okay, as you can see, we got two trays just full of parts. And I'm going to tell you, man, shipping really does a number on things. I don't see nothing damaged, but one thing that I am worried about, and I've seen this in several other people's videos, these servo motors that are sitting here, the set screws fall out of them, and I found one set screw laying in the box. So I'm going to have to get these under the light and make sure that the set screws are, I see just one missing here, but I got one in my hand. So I think both of them are in that motor. Hopefully we're not losing or missing any of the set screws. I'm not sure if these are standard size or what they are, but you can see the motor plugs are just full of foam, and I'm going to have to get all those cleaned out and blowed out. And you see this here mostly has the framework. This is the framing that's used to put the main printer together. I'm not going to lay that down. Over here is the hotbed. Extruder and wire cables and all kinds of nice stuff in here. And one thing I do not see in this package is usually right here is filament. Now, every one that I've seen that's opened this up has a roll of filament. Here is some filament. And they sent some small filament, PLA filament. But I was expecting to see a roll of filament in here. And You see European plug, so we're gonna have to change that over to US style. But anyway, I guess I'll get all this out of the box, get it laid out, and we can start assembly on it. Now I'm not going to do the whole build on this thing on cam, because you can go online and find quite a bit of videos of putting this thing together. So we'll get it together, and then after I get it together, I might take a few shots here and there of the build and talk about a little bit and about some of the problems or things I'm encountering in putting it together. But we'll go from there. Alright, I got everything laid out here on the table, and it looks like everything is here. I did find one more set screw that was laying in the bottom of the phone. It was for one of the that second servo motor was missing one. There was actually a piece of styrofoam stuck in it. I thought that was a screw, but you see it comes with its own tools. There's a little Phillips screwdriver, some wrenches, some Allen keys. Comes with a bigger screwdriver that's reversible. Looks like it looks like just a USB flash drive, but what it is a USB to micro SD card reader, and that's what you put your programs on after you run them through your slicing software to install into the main motherboard to print your file on. Bunch of screws and nuts and bolts. So what I got to do now is clean up a lot of foam dust. You can see there's little pieces of foam everywhere and all in the floor. And I'm going to have to clean this up before I can even get started. I'm probably going to have to take each part and suck some of that foam off, because it's got static all over it, and it's just stuck all over everything. It made the trip all the way from China to here, and I'm not going to say that all this bouncing around was done over the water. A lot of it could have been done right here in the US. So yeah, the box took kind of a beating, but everything looks to be okay, and we'll go ahead and get it together. Now, they don't send washers. Now, this stuff is acrylic, and you see it's pretty thick acrylic, and we got to take this paper off, because I'd rather have the paper off and have just a black acrylic. And the way it is, this here goes into the other piece, a nut goes here and a screw goes here. They do not have washers on this side. So when I was in town the other day, I went ahead and bought 125 of these little 3mm washers, just to give everything a nicer look, and be more durable. But anyway, we'll get started and start taking the paper off all this stuff, which is going to take a while. The build time on this is somewhere between 6 to 8 hours. So we'll see how that goes. Okay, less than 3 hours in, as you can see, pretty much got most of the printer together. All the hardware is put on, all but the display, the power supply, and the main board, and the wiring. So the 8-hour build time, 6 to 8 hour build time, I think it'd be done a lot faster if you go ahead and put your mind to it. So far the build is gone great. It's went together pretty good. I did run into a couple of problems. One of the first problems is back here in the back. You can see this limit switch back here, right there. The holes in the acrylic were a little bit oversized, so I had to fill them up a little bit to get those screws to hold. Also, there was one that's mounted right here. Same problem with it. And these are just like wood screws. They just screw into this acrylic. There's no nut behind it. Now the one up here on the extruder, there was no problem putting that one in. Those holes were fine. So yeah, little minor problem. Now under this bed there is 4 roller blocks that slide on this rod here. Pay attention if you get one of these and you're putting it together. Make sure there's no burr on the end of this rod, because when I went and installed one of them, it actually pushed 2 of the little ball bearings, and it's got a lot of ball bearings in that little slide pillow block, and it actually pushed 2 of those ball bearings out. I'm probably going to just go ahead and order the upgraded bearings to go in those, so it'll make it slide a little better than what it is. Now what I did, I put it together, it slides fine. I put dry lube on it also, and you know, that helps it slide back and forth, and no problem with the rest of it. Slides great. One more problem was I mounted the fan on here, and it comes with this little 3D printed blower nozzle, and it pops right under there. And it's already known there's a couple of issues with these. These point directly at the extruder head, the nozzle, instead of at the work that it's building. So one of the first things you do when you build one of these is print a better fan blower. Also, when I went to try to install this into the hole in the fan, it popped the fan open and broke one of the tabs off. Now I just put a, drop of super glue on it from tab and the fan's okay. But this is actually a little bit too big to fit in there, so it's got to be sanded down. And it's supposed to be beveled just a little bit so it slides up in there and holds. So I'm going to have to cut these down a little bit with a sanding block and get them right. The width is fine. It's the thickness here that's a little bit too much. Like I say, this fan is in 2 halves. You can see one of the mounting tabs right here that's around it. And what it done, this tab here that's on the front side, it cracked the little tab off. So I had to glue it back in place. So yeah, I have to work on that a little bit. But yeah, the build's going along real good. No problems other than them little minor things you see. It's very easy to put together. Getting this paper off this acrylic blocks, that's a bit of a chore. It takes a little while to do that, but what I did was just grab the parts that I needed that I was working on, pour the paper off, put them together, put it on. Grab the next thing, did the same thing, rinse and repeat. So now I'm getting ready to install the display up here, and once the display is installed, I can get the motherboard installed and then get the power supply installed. Anyway, just want to show you where I was. Like I say, less than 3 hours so far. Well guys, I'm going to go ahead and tell you, it really seems to be a decent printer. You know, I am no 3D printer expert, that I can tell you. I have operated CNC machines for a long time, and you know, basically this works just like a CNC machine. It does have some design issues, yeah. The unit is pretty sturdy. As you can see, there is hardly no wobble at all. But you got to make sure you got it on a flat surface. Now I happen to had something under the front that I didn't notice, and I leveled the bed, and when I moved it, I checked the level again, and the nozzle was jamming on the table. In fact, it tore this tape off that they had. It ripped that part on it, so I had to go back in and check everything. So it'd probably be best if you was to cut out a thick board about the shape of the footprint of this thing and mount this thing to it. That would help, you know, help it keep it more level, so you don't have to constantly adjust the bed. I had started, it was late last night when I got a chance to get back in here. I had started printing out it's a brush holder, and what it is, it's like a cup with a barrel on the front of it, but I didn't want this thing to sit here and run by itself because of the, as you can see, this is the spool holder, and this is all the PLA I've got at the moment, and it does kind of hang up a little bit on this without being a proper spool. I ordered some more PLA. Will be here tomorrow, and I'm going to go ahead and probably print a top spool holder, so the spool will sit up here, and this way the filament can go straight down into the extruder instead of having to come up over and rub around the top of it. Let's see what else. I'm going to look at printing some X braces to go into the bottom down here on the front and the back. And what this does, this keeps, when you tension this belt, it keeps from pulling so hard on this, and keeps that more secure. The belt tensioner, that you can print out an adjustable belt tensioner. I'll be making that. That's where you have a knob here where you can put tension on the belt. New fan blower. I did get this one on after sanding it down, and it's working okay, but it, like I say, it blows more on the nozzle and not on your part. But I will say that, you know, this is white, and I know it's hard to see on the camera, but it's really got a decent print quality to it. I mean, the side here is just as smooth. There's no bad looking bumps or ridges or anything in it. It really prints nice just from printing this little part, you know. So I'm real impressed of the detail of how well it prints. You could get in there, I don't know if y'all can see it on this. It's hard to see. Now if you see this line right here, it's actually started printing a design in here, and that's what that is. But I know y'all can't see it on camera, but you can see some real fine lines where the, you know, the extruder goes across this way. But other than that, it's not bad at all. It's pretty nice print quality. But we'll get some more things printed up on it and see how it looks. Like I say, there's a lot of mods that can be done. You can go to a different extruder that's, you know, supposed to be a better extruder. To have a problem with it blowing the MOSFETs on the main board, so they make new MOSFETs that go on the board. They do not mount on the board, they mount somewhere else and then solder into the board. Maybe looking at that, but we'll see how it goes. I guess, you know, wouldn't hurt to have a fan blowing on them, on the stock ones, but it's pretty cool back here in the office. So there's no problem. Got the air conditioner on or ceiling fan on. Now in the Y axis, you can see the belt here. This front and the back kind of runs uphill. They make a block that you can print that will actually bring this belt even, so it's not at an angle. That changes the tension on the belt. And if you ever have a problem with running X, Y, and Z on this, or a CMM machine or a CNM machine, you know, the finger pointed out this way, one pointing out, one pointing up, so that'll be X, Y, Z, and that'll always remember, just remember X, Y, Z, and that's your 3 axis that it runs. But yeah, we'll have to get that sorted out for the Y axis. Another issue that I have seen online is the hotbed connector back here at the back. This is powering there's actually a circuit board under this bed, and it's called the hotbed. And what it is, it's just got printed circuit traces in it, and it heats up and heats the bed up to about 70 degrees Fahrenheit. They have a problem with these cheaper made connectors melting and burning up, and your hotbed will no longer work. If you have that problem, remove this connector, solder the wires directly onto the hotbed. Now, you know, it does have an issue of having to remove the hotbed, which you shouldn't have to. Okay, I'm going to do just a simple little test print. I've already went to the menu. You hit the menu button, come down to okay, it's not going to let me get into it. You will scroll down to prepare, and then I scroll down to hit PLA, heat PLA, and then hit the button. So what it's doing, the nozzle temperature is coming up, and it should come up to 200. I've inserted the SD card. I went into it to initialize the SD card. Print from SD card, and I selected a test file that's going to print a box. So since it's kind of early in the evening, we should have enough time to be able to do that. So when this gets up to about 200, the nozzle should be good and hot, and the bed is warming up. So as soon as it gets there, it should start printing. Alright, you just hit 200. I'm not sure if I got the level perfect. I think I may be a tad too high. And if you do not have it leveled perfectly and the gap right, it is going to cause problem with the filament from sticking to the bed. But we'll just see how this goes. It's always important that your first layer to stick to your bed good. If not, the whole print could be damaged by warping, because your plastic has nothing to adhere to. So I'll let this go ahead and print and see what it does. I will tell you that when it starts out, it prints filament around the part, and that's just to get the extruder, you know, cleaned out, and then it actually starts to print. But we'll see how it looks after it gets done. I'm not going to sit here and film the whole printing process. And usually it tells you how long it's going to take to print, but I do not see, you see the print time is 00.02, which is incorrect. I just want to show you, you see right here where it's kind of messed up there on the edge of that print, and that's because the filament started hanging up and it couldn't pull the filament like it's supposed to. You can see the filament coming in here, and that's from that small spool of filament getting caught on the filament holder. Alright guys, the print is finished. I'm sorry I didn't get more video of the print itself, but a lot going on in here tonight, so just in time too. As you can see, that's what's left of the little package of filament. About 16-17 inches left, so it was just about out. And all I printed was this part that I had started to make a test print on, and the box itself. So let me get the box off in there. I have to move the camera out of the way if I can get to it. Okay, so there we are, and I've got to tell you, it's turned out pretty good. It's very smooth. You can see, I'll get the light on it, you can see the little tiny ridges in it where it printed, but there you go. But other than that, it turned out real good. Looks nice. Made a little thick on the bottom and the sides. And this shows that you can take this, and one thing I like to do is make project cases to hold electronics. Now I can simply, you know, have made this a little thinner, and I could have put standoffs in it to mount, you know, a PC board. Could have put holes in it and holes in the front to mount controls or whatever in it, you know, by using Tinkercad. You can download Tinkercad and you can go in there and make all kinds of things, and then move it over to Cure and slice it up, put it in. But yeah, I'm really amazed at the quality that this printer done on the first print, and that's without even, you know, taking it and fine tuning it, you know, which is something I will have to do later on, but you know, just for a test print, not bad at all. Now I ordered 2 rolls of filament. I ordered some white and I ordered some black, and this is 1.75 millimeter PLA, and I ordered 2 big rolls of each, because I knew this little roll wouldn't last long. But yeah, it did a real good job. I'm very impressed. There's no stringing on the corners, as you can see. This is just how it came off the hotbed. I haven't cleaned anything up or anything, and yeah, it looks decent. See good sharp angles on the corners. No problem at all there. I'm real impressed with this machine. This machine roughly runs about $200 on Banggood. I've seen them other places for like $240. I've seen them download for like $180. But it's basically, you know, about a $200 machine. You know, it is a do-it-yourself kit, so you got to spend some time. Like I said, build time, they estimated 6 to 8 hours. I got about 4.5 hours in the build. No problems at all. Everything went together pretty smooth. It's very straightforward. It comes with this little drive, and an SD card plugs into the back of it, and it has some test files, and it has several pieces of software in it. Cure, and I think there's 2 more. I haven't looked at it. Also has the instruction manual and troubleshooting manual and parts list on that drive. First thing you need to do is plug this in your computer and download all the contents to a folder, because I hear that this little drive doesn't last long. I've seen some people say that, you know, the first 30 days it fails, but you know, you can tell it's a cheap little drive. So I will go ahead and pick up a your choice of USB to micro SD card converters. I've had several of them myself. You know, it wouldn't hurt to go ahead and pick up another couple of SD cards. I have DigiPro, and it carries several different sizes of SD cards, you know, and it just plugs in. So yeah, it's good to have that. All you do is just, you know, pull the SD card out, or save your project from Cure to the SD card, pop it in the machine, and you get the camera moved. Just pop it in the machine and bring up the button, print from SD card. The files that I have is under the English material, and test file G code, and there's several different test files that's in here that you can print. So you know, it's very easy to use. This, you know, everything's straightforward. That was really I didn't even have to look at anything to figure out how to print it. I just went straight to the screen here, and you know, pushed the button and went right straight to what I was looking for. I didn't have to go online or anything, or in the manual to find out how to even print. Cure does not have this printer listed in it, but there's several guides to tell you how to set this up. The test files, you really don't have to worry about it. But if you're going to sit down, you're going to, build up your own G-code, you'll need to set the printer up in Cura. So that's not very hard to do at all. I'll show that in another video. As I said, there's many projects that we can do with this printer. So many things that we always find that we need. We can't find it. It's vintage. It's old. It's not available no more. Without tearing something apart and taking the part out of that to fix something else. With this printer, we'll be able to print a lot of those parts. Little plastic pieces inside radios, knobs, buttons. The possibilities are just unlimited. And like I say, project cases to house your electronic projects in. It's just, it's endless of what you can do here. Another thing that I wanted to do, y'all remember the old Heathkit RF probes? I really love these old probes, and they're getting harder and harder to find, especially in good shape. Now this one is just an RF probe. It doesn't have the audio circuit in it, so there's no external switch on it. I've already found some tubing, some aluminum tubing, and I've got a stick of that, but these ends are plastic. With this printer, we can print, go into Tinkercad, build these up in Tinkercad, switch it over to Cura, and slice them up and make the ends for it. And it's just a little circuit board in there with your components that you need, and cut the tubing to put the switch in it for RF and audio. So we'll be able to even reproduce some of these to look like the original RF probes. So that'll be one project I'm going to do, because I have several pieces of test equipment I would like to have the original looking probes for. So why not make them myself? Yeah, you can find them from time to time on eBay or so forth, but it's just as easy to build something. And building is fun. And one of the first mods that I'm going to do to it is to turn this machine off and on. You simply just plug it in into the mains power. There's no power switch on the machine or anything. So one of the first mods I'm going to be doing is printing a cover that goes around this power supply, and it will also have a off on switch, a mains connector, computer style connector, and a fuse holder, so that you can turn the machine off and on without having to plug it in and unplug it. Bit of a safety thing. The AC power cord just comes in, connects into the power supply, so there's no off on switch on it. So we'll be doing that mod, and several other mods that we'll look at doing to this machine. And here you see I've loaded up our first upgrade part here in Cura. And all you do is just click the folder, go and find the file you want, double click it, and it puts one of these rails on the platform, and you will right click it and hit multiply, and it'll ask you how many, and you just say 1 and then hit OK, and it'll give you a second one, since we need 2 of these. And what these are going to be are the spool holder that mounts on top through this little slots here, and then you put your spool on. This way it puts your spool up above the machine, so it doesn't have to pull the filament off the spool up over top and then down to the machine. So after you do that, you come over here and you click on File. You go down to Save G-code, and you name it what you want. Then you just take that and copy it over to your SD card and stick it in. And when you're in Cura, you can move this around and take a look at it. or whatever you want to do. So yeah, it's pretty neat. And here we are printing the actual part out. And as you can see, I got some new filament in there. It arrived today. I actually got 2 rolls of filament from Amazon for $19 a roll. And this is 1.75 millimeter PLA. So I'll go ahead and let these get printed up. And again, it's not telling me the time on this. Cure says 6 hours 39 minutes. But we'll see just how long it takes to do it. Sometime, way I understand, Cure isn't completely correct on the length of time that it takes to print. So we'll just see how it goes. Maybe it won't take quite as long. this print is at 98% done, and you can see so far it took 7 hours and 7 minutes to print. Now this is not a solid print. It has the honeycomb filler inside of it, so that kind of speeds up the printing. Okay, we just hit 99%. He's just about done. And she is done. Okay, and that's part of our new installed filament holder. Now you can see it doesn't quite fit. The bolt that's going through here is not long enough, so I'm going to have to get a longer piece of threaded rod. And now we have to print the nut and bolt that actually holds the filament. It'll be a plastic nut that fits in there and takes up that slack that's in that hole there. But I'll go grab a another threaded rod and cut it to length. You can see this one's kind of leaning just a little bit. And that was leaning in just a hair too. But yeah, longer threaded rod will solve that problem. This way the filament, you know, can just be poured straight down into the extruder. Okay guys, the first modification is complete. We have these upper arms attached to the top piece of acrylic, and it printed out a hole in the back side. I went ahead and drilled a hole all the way through it, put brass bolts in it to just, you know, give it some stability. This PLA, when it came with a I think it was a 1.1 inch diameter hole. Some of them were 51 millimeters. This here is like 22 millimeters. So I couldn't use the plastic printed nut and bolt that I was going to make for this. So what I've done, I got a piece of 3/4 scheduled conduit, which is it's probably PVC, but it's the gray type, and I got 2 end caps on it, and I just drilled the center of the end caps out and got my longer threaded rod and put through it, and put it all the way through it, and put a nut and washers on both sides. Just holds that pretty rigid. Now the filament can be poured directly, you know, into the extruder without having to go up and over. So yeah, that's the first mod done. Okay, our last test on this for today, or for this video, is that we're going to put our USB stick in our drive. We're going to come here, load a file. We're going to load the 3D Benchy. And it'll come up and it'll load in just a minute. And there it is. Now we want to save it. I'm going to just rename it Benchy. Takes 2 hours and 5 minutes to print. Takes 3.86 meters of filament. It's going to weigh out about 12 grams. So I'm going to just go here and eject the drive. Drive is ejected, and we'll just pull the SD card out the end and install it in the machine. Okay, the next thing we're going to do is come here and install the SD card into the port. Plug it in, and we'll hit the button once. We'll go down to initialize SD card, print from SD card. Oops, wrong button. I think I put it in the test file G code and Benchy. So what it's going to do now, it's going to heat the filament up to 220 degrees, and it's going to raise the bed temperature up to 70. Right now the nozzle is 36 degrees C and the bed's at 25. So that'll take a few minutes to do, and as soon as it gets to those temperatures, it'll start printing. Okay, nozzle has reached the correct temperature. As you can see right here, we're still waiting on the bed. It's at 51 degrees. Now the 3D Benchy is actually called the torture test for 3D printers, because it's got so much things that it has to do to create this little boat. So as soon as it gets printing, we'll see how it starts. Okay, she's at bed temperatures at 69. She'll be on her way in just a minute. And she's getting ready to start. Alright, so there you go, the 3D Benchy. Now, like I said before, the thing about the 3D Benchy, it puts your 3D printer to a test. And this little small item has a lot of things in it that really put this printer to the test. You know, you got a lot of angles, a lot of overfill, where it has to build up over these little doors and then has to build the top. And the first thing I've noticed about this is very little stringing. You see a couple right here on the bottom of the window, and a little bit here from the box to to the fishing rod holder here in the back. Back in the back, it looks good. Looks good around here. It's got 3 benchy on the back. You see the writing on the bottom. It did seem to struggle a little bit around the front here and the overhang. You can see some bubbling. I can't see any warpage. You know, that's not bad for a cheap 3D printer. It's not bad. Like I say, I'm not a printer expert, you know, but I've already looked at a lot of people print these out online. And this, you know, probably need to go in and change some settings. And that would help with this bubbling here around the bottom. But like I said, you know, you can see the angles that it's having to print in. You know, the slope going up on both sides, you know, and then this big slope here in the front. You see it's a little rough down here at the bottom, but the top edge looks perfect. A little bit of overfill here in the doorways, in the top of the porthole and the front window. Just a little bit, not a lot. But that really looks good. It's supposed to be 48 millimeters tall. And let's see here. It's exactly 48 millimeters tall. 15.5 millimeters wide. No, excuse me. 31 millimeters wide. And she's 31 millimeters. $60 millimeters in length. Make sure we get it square. 59.8. Close enough. 7 millimeters on the top of the chimney. So about 6.9. Well, 7 depends on how you load it. This is like one of these Harbor Freight calipers, so it's not the best. Anyway, 3 millimeter hole in the top of the chimney. Dead on. I'm very happy with it. Like I say, a little bit more fine tuning to it, and I think this thing will be perfect. Okay, and a big thank you to Banggood for sending this in. This is really going to come in handy here for making different projects and needed things for shop and vintage radio. So big thank you to Banggood. And like I say, I'll leave a link down below. And the click the show more tab. I'll give a link to the 3D printer. I'll also leave a link to the PLA that I bought. So anyway, hope you enjoyed this video. Like I say, we got a lot more upgrades I want to make to this, and we'll get into printing some needed things. Anyway, we'll catch you in the next video. Bye now.